Good morning and welcome to our 1-9 lesson today. That is understanding scientific notation. If you have me for math, we're going to look in our note packet and find the page that says 1-9. Okay, starting off, just want to copy down our definition. What scientific notation is. It's the product of two factors, one greater than or equal to 1 and less than 10, and the other a power of 10. So it always ends up looking something like this, where we have a number. This first one is greater than or equal to 1 and less than 10, and then times 10 to the power of another number, okay? And we will go ahead and explain that in our examples. So example 1 here is Louisa is researching the approximate distance between Earth and the Sun. Her father told her that the distance is 9.26 times 10 to the 7. If you can't see that, let's write that a little bit bigger. 9.26, I'm sorry, not that, 9.296 times 10 to the 7. And in astronomy book, she found that it was 92,960,000 miles. Okay, and so it says, which distance is correct? Well, first of all, we have to compare the distances. And if one is in standard form and one is in scientific, then we have to take one out to match the other. So I'm going to take the one in scientific and I'm going to write it in standard. So this 7 right here tells me how many spaces to move the decimal. All right. And since it is a positive 7, we know that this is going to end up being a big number when we're done. So that tells us that I'm going to have to move the decimal to my right. If I move it to the left, I'm going to make a smaller number, but moving it to the right will make a larger number. So I'm going to rewrite this 9.296, and I'm going to start moving this decimal. 1, 2, 3, 4, 5, 6, 7 spaces. And then there's going to be some empty spaces. I will fill those with zeros. Now, this is hard to see still, so we don't want to leave this as an answer. We want to write it without all the waves, and we want to make sure that the correct decimal stays in place. So 9296, and then it looks like we have 4 zeros after. 1, 2, 3, 4, and the decimal point is at the end. Okay, so let's take a look. It might help us to put commas in here to compare it. So every 3, we will put a comma. And if you take a look at the book and then what her dad said, they are the same distance. So they are both correct. Okay, so that's our first example. I'm going to leave the try it in case you want to do one on your own. And we're going to move on to example 2. So if we slide up here, here's example 2. And I rewrote the number that's on the cell here so that you can see it. But the example says this: what is the width of a red blood cell written in scientific notation? So this picture right here is of a red blood cell, and it says it's 0.0000703 meters in diameter. So what we want to do is we want to write this guy in scientific notation. So this is a really small number. And what we do for scientific notation is the first number has to be between 1 and 10. It's got to be greater than or equal to 1 and less than 10. So the only way to do that is we need to move that decimal. So we want our decimal to land after our first non-zero digit. So after that 7 is where we're going to want to put it for our answer. So I'm going to start this by putting 7.03. And then the second part of scientific notation has to be a power of 10. So we're going to multiply by 10, and the exponent is going to tell us how many spaces we must have moved the original decimal to put it where we put it. So let's count. Starting where it started here, we've got 1, 2, 3, 4, 5, 6 total spaces. And since this is a very small number, that is a negative exponent, so it's a negative 6. And this is in scientific notation. One thing to note on here, right, is that I'm not counting the zeros behind that decimal point. I'm counting the number of numbers between my two decimals. So the 7 counts as well. So don't try to cheat and say, oh, the number of zeros is this many, so that's my decimal. You have to count the spaces. Okay, one last example here. And this is important because our calculators um, say this a lot when we put things in it. Um, so the calculator, when they do scientific notation, it has a little e in it, like this. It says, might say 3.5 E15. That's really the calculator shorthand of saying this is in scientific notation. So example 3 says, Kelly used a calculator to multiply large numbers. How can she write the number on her calculator screen in standard form? Okay, so this calculator says 3.5 e to the 15. In scientific notation, that would be 3.5 times 10 to the 15th power. That's what that's telling her. Now, we just learned that this exponent, this 15, tells us how many spaces to move that decimal point. And since it's positive, it's going to make a really big number. And so we're going to move that decimal to the right 15 times. Okay, so I'm going to start with 3.5. And I'm not going to get 15 zeros because one of the spaces counts this 5. And so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, ending there. So notice I don't get 15 zeros, I get 14 zeros because one of them was taken by the 5, one of the spaces. That is a big number in standard form. But again, we do not leave our answer like that. We don't want to do that. We want to make sure all these little wavy lines are gone and we keep the correct decimal. So the decimal we want to keep is this end one because that's where we landed. So we need a 3 and a 5 and we need 14 zeros. You're going to have to write small. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 decimals at the end. And a lot of times in standard form, you want to go through and put commas in if you're working with big numbers to give your readers an idea of just how big that number is. And that is the final answer here in green. Okay, let's do part B. How can Charlie write the number on his calculator screen in standard form? So his says 8e negative 9. And so again, that means scientific notation. So what that really means is 8 times 10 to the negative 9 power. Okay, so this is a little bit different. Notice there's no decimal point here on this 8. So something that we learn in early math is that if there is no decimal point, it's automatically assumed that it's at the end right here. That's like 8.0, right? And so when I do my answer, I get to start with 8.0. Oops, I'm going to move it over. So 8.0, notice I'm putting it over to the side a little bit instead of right here, which I originally had put it. The reason is because I have a negative exponent. So that means I'm going to make this smaller. So if I started moving out to the right, it's going to make it a larger number. This decimal, since it's negative, I'm going to move it out to the left and make it smaller. So I'm going to go left 9 spaces with this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we can stop and put zeros here. I'm sorry, got small. But again, notice there are not going to be 9 zeros in there. One of those spaces was taken with the 8. So we want to write our answer out without all of those wavy lines. So we have 1, 2, 3, 4, 5, 6, 7, 8 zeros, then an 8. And then we really have another 0 there, which we can include, but we don't have to. So that's our final answer. Okay, hopefully this is helpful for you. Again, there's some try-its underneath there that you can do. If you have me for class, our assignment today is in our book, and we are going to be working on pages, let's see, pages 62 through 64 and numbers 1 through 19. Okay, if you have any questions, oh, can't see that on screen. Sorry about that. If you have any questions, please email me or see me when you can. Have a great day.